Welcome to the second session on simple commands in Linux. So here we explore some more commands in the Linux operating system, and it is hoped that at the end of this session you will be more comfortable with the command line environment and also looking around in the file system and knowing about the machine a little more than earlier. As you know, we have been introduced to the /, which is the character used to separate the directories within the file system hierarchy, and it is also the name of the root file system, the starting point of the file system in the Linux environment. We will see that we can use the / multiple times, and it is as good as using just once. And if we try to access the parent folder while in the root folder, we would actually stay in the root folder, which actually means that the root folder is its own parent. So as we said, multiple uses of the / is as good as single usage. So I want to visit the user bin. So I would type multiple times, and you would see that I am in the same directory as /user/bin. I now go to the root folder and try to access the parent folder. I see that I am in the root folder still, and you can do it multiple times, and it just implies that the root folder is its own parent. The ls command has both short and long forms of the options, and when you give a directory name as an argument, the way it is interpreted is something that we will see in a moment. And you can actually recursively list the files and directories within a particular folder using the -r option of ls, and the sequence of options to be given in the command line for the ls command is also something that is very flexible, and we can look at it in the demo. Let us explore the home directory a little further. So I am now in the home directory, and when we give the -l option to the ls command, by default it is showing you all the files and directories within the current directory. Now if I were to give a folder name, let us say level 1, then it would show what are the files and directories within the directory level 1. So it would go below the level 1 and then show you what is there inside. Now I want to only look at the permission string and other details in the long listing format of the level 1 directory, but not what is inside that. So for that, what we need to do is give additional option D, so that it would show you a string giving you the long format for the level 1 folder, as it is also shown along with other files when we did it using the command ls-l. So you see that this -d option is basically triggering that you should not traverse inside the directory and show the listing. We could also look at multiple options in one go. So -ldi level 1, and you would see that we are seeing the inode number, and we are also seeing the long listing format, and also for the directory which is level 1. Now we may give these options in any order. So let me clear the screen. ls -l level 1 and then -di, and then I would change the sequence -t level 1 -li ls -i level 1 -ld ls level 1 -ldi or idl. So you can see that I am giving the options in very many ways, but the output is identical. It just means that the ls command really doesn't bother about the sequence of the options. It would take all the three options that have been given to it and then produce the output, which is basically the long listing for the folder level 1 along with the inode number to be displayed on the screen. Now this flexibility in terms of giving the option either before or after the argument is not available with every command, because sometimes some of the options require the argument to immediately follow them, in which case the sequence of how you provide them on the command line would be quite important. So generally it's a good idea to follow the sequence in this following manner, where the options are in the middle and collected together as far as possible, and then the arguments are following after that. Okay, so this is the very standard way of writing a command. If you see the man page for the ls command, you would notice that there are some options which have a a long format also, that is a long option also is available, and they are basically equivalent, and some of them do not have that. For example, -L does not have a long form, okay, whereas if you look at the -I, it has a long form -inode, and then if you look at D, it has a long form called directory. So which means that I can actually type in this manner -I D L and then level 1. I could also type in this manner -L minus minus directory minus minus inode level 1. So you could see that the output is same, except that in this form, if you write, the intention of the command is very clear, because the long form of the option is a little more human readable. However, it is only for those who wish to type a lot, but it's a good idea to also learn the short form, because the beauty of the command line environment is also to be able to write very short commands that do a lot of work. So there are some commands available which help you know the content of a text file a little more. So we have already seen the less command, and now we would see the WC command, the head command, the tail command, the cat command, and the more command. All of these let you inspect the contents of a text file. We will take the example of /etc/profile to use these commands. So we go to the /etc folder, which contains the configurations, and there's one configuration which will be very important for anyone who uses a shell, and that's called the etc profile. Okay, so we will understand what is in that profile later as we learn about the shell scripts, etc. But for now, let us look at the content. So ls-l profile, is there any file like that? And you see that yes, there is a file like that. Okay, now what are the contents of it? So earlier we learnt about the less command. So if you type less profile, and you would see the contents of it, and when the contents are scrolled at the end, you can actually see that available as bracket END, which means that the contents are over, and you may now press Q to come out of it. So this is a short file fitting in one screen itself. Now there are also other ways of looking at the content. So cat is one such command. So it is to catenate or concatenate the text onto the screen. So if you type cat profile, it would just dump the contents of that file onto the screen and then exit. So there is no more prompting that is required for you to come out by pressing a Q or anything like that. The disadvantage of cat is that you can't actually move back and forth to look at the content page by page, and you can't also come out halfway through when the text is being displayed on the screen. Whereas in the case of ls, you have such features. So sometimes if the file is very long, cat is not the best way to look at the contents, because the file would keep scrolling on the screen, and depending upon how many lines are stored by your terminal emulator, you may not actually be able to see the initial content by the time it finishes displaying the whole file on the screen. Now there are some more such commands available. So let me clear the screen now. More is also one command available. So more is going to behave similar to less. It would also allow you to look at the contents of a file page by page if there are multiple pages. Now you may also look at it just the first few lines or the last few lines. So there is a command called head, and if you type head profile, you would see the first 10 lines. So let us look at the man page of head, and it shows you here that it actually prints the first 10 lines of the file. But if you are interested in less number of lines, you could also do that using -n and then the number of lines. So let us do that. I would say type -n and then just the 5 lines of the file called profile, and you see that exactly 5 lines have been displayed. There is another command called tail. Okay, as the name indicates, you can view the last few lines of the text file. Tail profile. So you can see that the last 10 lines are there. Let us look at the man page for tail, and it tells you that it prints the last 10 lines of the file to the screen. So just like head command, the tail command also supports reducing or increasing the number of lines that are to be displayed. So here I am trying to show the last 5 lines of the file profile, and here are the last 5 lines. As you can see, there are multiple ways to inspect the contents of any text file within the Linux environment. Before you open the file, it may be a good idea to inspect how many lines are there, how big is the file. So there's a command for that called wc. Look at the man page of wc. It tells you that it will show you how many new lines are there, which means how many lines are there, and then how many words are there and how many bytes are there in each of the text files that we are giving. Okay, so let us go ahead and run it on the file profile. So wc profile, and it says that there are 27 lines in that particular file, and there are 97 words, and then 581 bytes it is occupying on the disk. So if you look at the content in the long listing, it would show you that 581 is the size of the file called etc profile. Now sometimes we are usually interested only in the number of lines for the purpose of trimming some of them, displaying a specific line, etc. So for that we may use the option -l. Okay, so it just gives you the number of lines. Now we may be interested in knowing where are these commands, and where are they located, etc. So there is a command called which. Okay, so we say which less, and it will tell you the location of that particular command. Okay, it is sitting in user bin. So we may want to know what is this which itself. So man which, and it tells you that you can actually locate the command. Okay, so there's another command called what is, and using that you will have a very brief description of the command. Okay, so man page is showing you a complete manual page, but what is would show you just the first line of the man page where the brief description of that particular command is available. Now you will see that there is also another command called more, and you would see that this command is also in user bin. So let us see these two, how big they are. ls -l, and then I give the path to know more about them. Okay, and ls -l user bin more. Now you could see that the command called more actually occupies less space. It is a smaller command, and the command called less is actually a bigger executable. You can see that it occupies 180 kilobytes. The joke about this in Linux is that less is more. We have seen that the manual pages which come bundled along with Linux help us in learning more about a command, and often we may want to discover more commands for a specific purpose. So you could search for them, not necessarily going to the internet, but within the Linux environment itself at the bash prompt by using the apropos command. So what it would do is, for a keyword it would show you all the commands which would have that keyword in the description, and you could also actually browse through various sections and various commands in those sections using a system called info. And once you find out the name of any command, you can learn more about it obviously from the man pages, but also to know where is it located and what type of a command. Is it a script, or is it an alias, or is it a binary file sitting in one of the binary directories like user bin, etc. So we can explore the commands all by ourselves without having to go to the internet, using these set of features that are available with the Linux operating system. Let us have a demonstration of how to discover new commands by using the features that we have just now mentioned. So apropos, and you can give a keyword which would be searched for. So let us give a keyword like who. So I want to know who are all logged on to the system, etc. Okay, so when you type apropos who, it will give you a set of commands which will help you to know who are logged on, and one of them is the who itself. And of course there's another command called who am I, which we have used in one of the earlier sessions to print the name of the user who is logged on. Okay, now obviously to know more about it, you can type man who and learn more about it from the manual pages. Okay, and what is this command apropos? You could actually ask for it by typing which apropos, and you would see that it is sitting in user bin apropos. There's another command called what is. What is, and let us say who. So if there's a command called who, I want a brief description of what is that command and what is would actually do that. Okay, so you could say what is ls, what is ps, what is wc, what is less, what is more. Okay, so you could actually ask what are those commands and what is would give you a very brief description of that command. Now you want to see where is this command located, namely the what is command. So which what is would tell you that it is located in user bin. So let us see whether these are both same or not. So if you type ls minus l user bin apropos, it appears that user bin apropos is actually a symbolic link to what is command. So it means that actually when you type what is or apropos, it's the same executable which is running. However, the output is different. For example, if I type what is who and apropos who, then the output is different. So how is this possible? The reason is that in Linux, every executable would know in what name it has been invoked, and depending on the name that it is invoked, it could actually have different behavior. Okay, so you could actually have these features tested out as part of your own bash scripts once you start learning that as part of this course. Now apropos is also having the same output as man minus k, and you would see that the identical output is coming. So searching for keyword using the manual pages is the same as what apropos is doing. Now there are also some more features that are available. For example, you can type for help, and what actually help does is show you certain keywords that are actually reserved for the shell which we are running. Which shell are we running? So we are running bash shell. Okay, you can see here we are running bash shell, and the help command shows you what are all the special words that are used by the bash environment. I will show you the info also feature. You could see that you could go to any section and you can browse through the commands, and you can put the cursor on any of the commands. For example, chmod, I will go there and then press enter, and you would see the information about the chmod that is shown here. And we can actually go back by using the left angle bracket, which is same as shift plus comma. Okay, and you come to the main menu, and you could then go to some other command and read about that, and then again come back to the main. So you can actually almost like a browser, text based browser, you can actually browse through the commands that are available in the info system that came along with the Linux operating system. Now sometimes you may want to know what type of a command it is. So type is a command to tell you what type of a command. So let us say type. So it says it's a shell bulletin. What it means is that the command type is actually being offered to you from the shell and not from the operating system. Okay, so type ls. Now it says that ls is aliased to certain command. So which means that it is actually coming from a command ls after having been aliased with certain option. Okay, and which ls will tell you that it is actually coming from the operating system because there is a executable available. Can we check about that? Well, you can see that it's an executable and it is sitting in the user bin directory. We may even find more about it by using the file command, and you will see that it's an ELF 64-bit executable for x86-64 architecture and so on, and occupying about 142 kilobytes, and therefore ls is actually an executable and therefore offered from the operating system, whereas type is actually coming from the shell. Okay, so similarly help is also a shell bulletin. Okay, so sometimes when you are running a command, it's a good idea to know, is it being offered by the shell or by the operating system, or is it an alias? So that brings the context to aliases. What are aliases? Aliases are nothing but nicknames that are given to certain commands. Sometimes you may want it for convenience. For example, you may want to very frequently look at the long listing of your directory. Okay, and you may want to give that as an alias. So I may say alias, and let us say long listing is equal to ls minus l. Okay. Now you see that ll is a new command that you have created, and if you type ll, you will actually get the long listing of the current directory. Now you can ask, what is this ll? And it tells you that ll is aliased to ls minus l. So you understand it's not a command coming from the operating system, it's an alias coming from what you have configured just a while back. Now you don't want that, you can remove that, an alias ll. You may want to find out what are all the aliases that have been configured for you in the bash environment when you logged on, and just type alias, and then you would see a list of aliases that are there. Some of these are actually created by the user, and some of them may be created by the administrator on behalf of the user by putting them in etc profile or some such script file which is executed whenever the bash environment starts. We will learn about that also a little later. Okay. Now you can always remove some of these aliases. So I want to remove, let us say, this alias. So I could just say unalias l. Okay. Now I will again type alias, and you could see that that particular entry has been missing. Now what happens is that if I type just l, obviously there is no such command, but earlier if you were typed, then it would actually give you the output which is corresponding to ls minus capital C capital F as the options. So by now you are familiar with the concept of arguments and options. Okay, so options are basically enhanced features of the command that we are giving, and arguments are specific names of files or directories that we are giving on the command line, so that the command would act on those respective files or directories as requirement needs. Now when we are writing a command, we could actually have multiple arguments on the command line, and the way those arguments are interpreted depends upon the command itself. So we should definitely read the man page of every command that we are going to use frequently to understand how this interpretation is taking place. So if you look at the commands like copying using cp or moving a file using mv, then if you give two arguments, what happens is something that we have already seen, and let us see how this is actually changing when the second argument is a directory, or if it is a last argument among many arguments that are given on the command line. And sometimes the recursion is sometimes assumed for some commands, and sometimes you have to explicitly state it. So let us look at that difference also in a moment. So we are now in our home directory, and we will see how the number of arguments can be specified. So I will take the example of touch command to create some files. Let me just see that there are no files in my home directory. So I will create some empty files for this practice. So I would say touch, and let us say file 1. Now if you give multiple files, all of them will be created. So this is the idea of multiple arguments. Okay, so if I give like this, it means that all the 3 files will be created in one go, and the timestamp will also be identical. Okay, so we have seen that these 3 files have been created. Now to illustrate the way the directory will be interpreted as one of the arguments in the copy file, we will create an empty directory, mkdir my directory. Okay, so then I would say copy file 1 to my directory, and what happens is that the file 1 has been copied over to my dir. So if you put ls, you would see that the file 1 is actually there in the home directory, but if you go to the directory my dir, and there is a file called file 1 there also, which means you have made a copy of that. Okay, now let us say I type copy file 1 to file 2. Now what happens is that if the second argument is a file, then you are trying to override that file by this copy command, and naturally it would ask you to confirm if you have given with the -i option, and let us say I don't want to do that, I say no, and I have given an alias for cp which is -i, and if you look at the man page of cp, -i would correspond to interactive, which means that it should prompt whenever there is an overwriting to be done. So it's a good idea to have that alias kept. Now let me go to my dir and remove this file and come out, and then I can now remove the directory also. So rmdir will remove an empty directory. Okay, now let me go back and create it again and see if I can do it without having to go and remove the files before I remove the directory. So I create the directory now again. Now I go to that directory and I create some file there. So you see that there is a file that is available, though it is a empty file, but it is still a file that is there inside. And I want to remove this directory. And now you see that it is not empty and therefore you cannot remove it automatically. So you may want to force the removal, and you could actually give an option called -r. So rm -r my dir, and it would then go ahead and descend into the directory and remove whatever is there in that. Okay, so it would ask each time, because I have asked for that alias -i option I have given in the alias. So you can see what is alias I have, rm -i. So because I have set the interactive option already, it would ask me. If I don't have that alias, it would not ask me. Let us test it out already. Okay, so I will unalias rm. Then I will again see what is alias for rm. There is no such alias. Now which rm? It says rm is a command. So you now see that this rm command is quite dangerous, because it would not ask you while removing the directory. Okay, so let me just try that out. Make dir my dir, go to my dir and touch a file. Okay, and come back to the home directory, rm -r my dir, and you see that it actually deleted the directory without even asking you. So which means that it goes by the philosophy of Linux of no nonsense, and you intended to remove the directory, and that's what has been done. So it's a good idea for novice users to use the aliases with -i, so that unintentionally you don't remove, and the prompting actually makes you think once more before you say yes. Now some options assume recursion and some options don't assume recursion. Okay, so here I would just show you. We make a directory and we go into the directory and create, let us say, 2 files in them. Come back to the home directory, and I want to look at the contents of my dir. So you can see that there are 2 files in them. Now I want to rename the my dir. I would actually just use the move command, but let us say I want to copy it to some other name. So what would happen? Copy my dir, and I want to copy it to another directory. The second argument is actually a directory that doesn't exist, and we would like to make a copy, and that doesn't seem to help because it's not a directory that is existing right now. So what you could do is copy -r my dir to my dir 2. So if you give the -r option, it would actually work, because it now has created the second directory. Let us go and see that. So it has the files that we have created. So which means that for the copy command, the recursion is not assumed. While copying, it is asking whether you want it to be recursive or not. Now mv command doesn't ask for that. You would see that, let us say I want to move the my dir to my dir 3, and you see that it just renames it, and therefore there is no recursion that is being asked for. So what it implies is that some commands assume recursion, some commands do not assume recursion, and one must be aware of that while playing around with those commands. A little bit of discussion about the links is worthwhile. So we have seen that both hard links and symbolic links are possible, and we can create them for a given file, and looking at the inode numbers, we can actually determine whether they are hard links or symbolic links, and also from the long listing of the file system also you could actually see whether they are hard links or symbolic links. Okay, now let us look at the hard link and soft link concept. So we have got the home directory here. So let us create an empty file. Okay, and you would see that the empty file is here. Now we would create a symbolic link to this file. Okay, so that is done using the command ln. So we would look at the man page for ln. So ln is for making the links. Symbolic link is done by using the -s option. Here it is -s option. Okay, so symbolic link and the source for which we are making the link, and the destination which is the link itself. So ln minus s source destination, that's how the format looks like. And now when we look at the long listing, you would see that file2 is a symbolic link to file1. Okay, and let us look at the inode numbers. You would see that file2 has an inode number which is different from the file1, which means that they are separate entries. The file2 is a separate entry, but it is just a shortcut to the file1. Okay, now let us go ahead and create a hard link also to file1. So the hard links are created by the link command without the minus s option. And now look at the inode numbers in the long listing, and you will see that the file1 and the file3 have the same inode number, which means that these two are basically the same file. And you would also notice the number of hard links here, it says 2, so which means that these files are having 2 hard links in the file system, whereas a link file2 has only one hard link, which is the symbolic link itself. Okay, so this is the difference, and you can actually note from this number here how many hard links, and from there we can actually guess that there are multiple locations for that particular file. Now a brief note about the file sizes. So we could actually get the file size from the long listing of the directory. We could also ask for the file size to be specified in the very first column using the minus s option of the ls command. There are also some more commands available to know more about the size occupied by the file on the disk using the stat command as well as by du command. And there is a role that the block size will play. To understand that, we will actually go through the demo. So let us go and look at these sizes from one of the system folders. So we will go to the user bin and type ls, and there are umpteen number of files, so we can inspect the sizes of these files here. Okay, so there is a file called znew. So let us look at the size of that. So stat znew, and you would see that it is telling you about the size, and the size, it says 4553 bytes, and how many blocks it is occupying, and so on. So znew is occupying 4553 bytes, and it is actually occupying 16 blocks, and you have the timestamps available here, which will tell you when was it accessed, when was it modified, and so on. Okay, now look at the same information using the du command. Okay, and it says that there are 8, it is occupying about 8 kilobytes. So we can actually use the minus h command, and it will tell you that, in a human readable form, it is about 8 kilobytes. Now why is it 8 kilobytes as far the du output is concerned, but the ls is showing you 4553? The reason is that the block size is 4 kilobytes, and the size is just above 4 kilobytes, so it actually goes on to the 8 kilobytes. It means that files that are actually smaller than the block size would actually take up the whole block. So you can have a block or more blocks, but not a part of the block. Now let us look at the zmore command, which seems to be just less than one block. Okay, and you understand that it would actually take the whole block. Okay, and here you see. So you could see that zmore, a command which is occupying 4 kilobytes, and it would actually have a size which is actually less than one block, only 1842 bytes, but it is actually occupying 4 kilobytes because that's the size of the block. Now there are some directories which you would see in the root folder, which are actually not sitting on the disk. They are only in the memory, and they are very special file systems. We should not be messing around with those directories, but we can actually view very important system information from those directories in a read-only manner, and let us explore those two directories now. So we will go back to the root folder and see that these folders are available here. You can see here sys and then proc. Okay, so what are these folders? These folders are actually not sitting on your hard disk. The proc and the sys, they are actually in the memory, and these are all basically directory structures available for the users to know more about their system. And the proc system, the /proc file system, is an older system. From kernel 2.6 onwards, the /sys system has been used. However, even now, the information about various processes that are running is still stored in the /proc directory itself. We can go in and look at that without much problem. Let us go there, cd /proc, and you can see that it has many files which are actually 0 size, and that would be a little bit misleading. The reason is that some of them actually have content that we can read, but the size will be 0. The reason is that it's only a representation for us to explore, but actually they are not real files which are sitting on the hard disk. So let us look at some of the contents. So there's a file called CPU info here, so which is actually occupying 0 bytes, it says, but let us look at its content, less CPU info, and you see that there is some information that is coming out onto the screen, and it seems to be information about the CPU. Okay, and we could also do cat CPU info, and you would see that several lines have come, and you can scroll with your mouse and read some of it. Okay, so it appears that it is giving you information about your CPU, and when you type ls-l, you would see that this file is actually showing as if it is occupying 0 bytes, which means that this is not real. It is only in the memory and as a placeholder for us to know about the system, and you can actually now know more about your system by reading some other files also. So if you type cat version within the /proc directory, you would see the information which is also available when you type uname -a, which is basically telling you about the kernel that is being used by the operating system, along with what kind of an architecture the particular machine is, and what is the operating system it is running, and so on. When you type meminfo, okay, cat meminfo, it will give you information about the memory, and this information is coming in various forms, how much of free memory is there and how much of total memory is there, etc. And this is also available to us through other commands, like for example free. Okay, so it is more readable. Free -h will actually give you in a human readable form how much of memory is available for more applications to be launched on this particular operating system. And you can also do cat partitions, and it will tell you how many partitions are there in this particular system. If the hard disk has multiple partitions, it will show you, and it will also show you the size of it in terms of number of blocks, but this is not very helpful. You could actually get the help using the df command, and a df command will actually show you more information, like what is the mount point, in which directory is that particular partition made available to the user, and so on. And if you type df -h, it will give you the information in a human readable form with respect to the size. So for example, my root partition happens to be 183 gigabytes, and of which only 30 gigabytes has been used. And my home directory is having a size of 481 gigabytes, out of which about 6.9 gigabytes has been used. Now if you go to /proc and look at the files, there is some file which actually looks rather big. You can see this, there's a kcore file which occupies a huge size, and it appears that this is a very big number. Okay, if you calculate, it would be how many zeros. If you calculate, it would come out to be about 140 terabytes. Obviously it cannot be a real file because our hard disk is itself just 1 terabyte, and therefore this cannot be coming from the hard disk. So this basically is an entry that tells you what is the maximum virtual memory the current Linux operating system is able to handle, okay, theoretically. And this comes with 47 bits for the virtual memory, and 2 raised to the power 47 comes to roughly about 140 terabytes. So this directory is very magical because there are files which are having 0 size but have content. There are files which have a huge size but actually don't exist on the hard disk. Okay, so /proc that way is a magical file system in which a lot of information is available for you to look at to know more about the system. Now there are a lot of folders that are also going down with some names which are basically numbers. These numbers correspond to what are called the process IDs. For every process that is running in the operating system, there is an ID, and using these folders we can know more about those processes. Similarly, the /sys folder is also the same kind of a file system, which is actually much more well organized than /proc, because it's a slightly newer development in the Linux. And here in a very neatly organized directory structure, you would see that the information about the system is all collected and available for you to read and process in your scripts or any other use that you may want to have. So let us go and explore some directory here. So I will go to /sys and then go to the bus folder, and in the bus I will go to USB, and then I will go to devices, and you see that there are some directories or links that are available. Okay, so these are all devices that are actually USB type of devices. Now let me go to the 1-1 directory, and there are some files that are here, and I can just read about them. So let us say less and manufacturer. Okay, and it says JBL is a manufacturer. Okay, and less product, and it says JBL Quantum 300 is the product name. So incidentally, this particular USB device that we are looking at is this headphone that I am using right now to record my audio. So the USB device is JBL Quantum 300. Okay, similarly, other devices also can be looked at. So let us look at, let us say 1-7 and less manufacturer. It's a PixArt is the manufacturer. Less product, it says Dell M116 USB optical mouse. That is this mouse, which is actually the USB device that we have looked at. So like this, every device that is connected with the computer, we can actually know more and more details about it just by simply exploring the file system that is already made available. So /sys and /proc are two file systems which help us to know more about the hardware, and we will learn to process such information as we go along. So I now encourage you to explore the file system and run the simple commands that we have discussed till now to understand your machine a little bit more.